Assalamu alaikum and welcome to our channel. I am Dr. Ismail. Today we will talk about density function theory, which is known as DFT analysis in GaussView 6. DFT analysis is just like a molecular simulator to predict the quantum mechanics. For this, the most commonly used software is GaussView. It is simple to use. Today we will talk about how you can install the GaussView, how you can use the molecular builder, the DFT analysis, the vibrational analysis, Homo analysis, Lumo analysis, Raman spectra, IR spectra, UV-Vis spectra, and analysis of the large molecules. In this tutorial, we will explain every step in comprehensive way. So, as I told you earlier, DFT is like a molecular simulator. It uses quantum mechanics to predict. What it predicts? That if you have a molecule, in this molecule where the electron are, where they reside, which means electron density can be calculated. The second thing is that how molecule vibrate, which means you can calculate the frequencies and even how they react. For reaction, we can calculate Homo and Lumo. So let's start. To run this tutorial, we need two software. One software is Gaussian. Today we are using the version 09, and the second software is GaussView. First we will install Gaussian. In the Gaussian, we have a setup file and a serial file. Serial number file came with your software. We will just double click on the setup file. It is now starting the installation. Click on the next. Then you can add your serial key and click on the next. If your serial key is correct, it will give the option that serial number is validated. Okay. And by these options, don't change anything. Click on next. It is default folder. If you want to change, you can change, but next, install, and it is now installing the software. During the installation, it will ask for the sketch file. Keep it default and press OK. And press OK, and the installation is finished. Now, the one software is installed, Gaussian. Now we are going to install the Gaussian view. For the Gaussian view, in the same way, double click on the icon. It is now initializing. Click on the next button. Next. Give it to the serial key. If the serial key was correct, it will give you the option that serial number is validated. Press OK. Keeping the default setting. Click next. If you want to a quick launch, it's your choice. Then click on the next. Choose all these options. Otherwise, your some file may be not read by the Gaussian or Gaussian software. Click on the next, and then again check mark on all the files. And then click on the install button. The installation is completed. Click on the finish button and we are done. Now we have two programs. This one is Gaussian on our desktop and GaussView on desktop. We actually don't need to run this. We will only work on this one, GaussView. When we open the GaussView, it will automatically connected with the Gaussian. So for here, I just simply delete it. So first step is open the GaussView. We are using currently the GaussView 6. This is our first window when you open. If you don't want to see this, just uncheck mark it and close it. Next time it will not appear. This one is our main window and this one is a new window. If it is closed, you can generate. Under the file button there is an option. You can generate a new one. This is the builder window. Here is the file in which you can do, then edit, tools, builder, view, calculate. We will use according to our demand. You can build as well as you can open an already existing file which contains your structure. This file can be in any format, SD format, mol format or PDB format. Simply, you just need to go to file and open. For example, I have placed a file 692.mol and you can open it. Would you like to add hydrogen to your structure? You can add the hydrogen, and so this file is now open. You can see this structure. Now we will demonstrate that how you can build your own structure. First of all, you can see this is a molecule, this is a carbon, and these are 4 hydrogen over it. Just click on it and then click here. Whatever is present in this window will appear here. You can use your mouse to rotate it or make it. You can use the wheel to zoom it. Now in the builder option there is a carbon tetrahedral. It is showing that this is carbon tetrahedral. You can choose any other molecule. This is the periodic table. You can see. Let me adjust it a bit. And these are the carbon basically. This is the tetrahedral, this is the chosen one. You can also choose as a single carbon atom. You can also choose as this one. You can also choose this one with 2 and so on. So just to add, I just choose this one and add to this hydrogen atom. You can see the hydrogen has been replaced and carbon has been added. Now at next level I choose nitrogen. When you choose nitrogen, it gives you multiple configuration of nitrogen, like which type you want to use. As this is the carbon atom bonded with this carbon atom and 3 bonds are free, so I am going to choose this one, this nitrogen atom. And I will click on the 3 bonds over here and this blue color nitrogen is added. So in this way you can build your complete molecule. You can add any further like boron, carbon, silicon, iron, whatever you like. For demo, we are just using this molecule for further demonstration. These are the standard bond length. But if you want to change the bond length, come over here in this where their nitrogen is terminal is type. Here is 2 lines. You can see there is 2 lines. It says that modify the bond. Click on it and then click any 2 items between which you want to change the bond length. Like you say, I have clicked carbon and then nitrogen. It's showing that the bond length is 2.94. I can increase and decrease. Just look at over here. When I increase, the bond length is being increased. You can choose as much as you like. This is your own choice. Right now I'm not going to change it anyway. I just want to show you that how you can change the bond length of your molecule. Now we move toward the DFT analysis. For DFT analysis, in the main window here is a button known as calculate. In this one, the first option, Gaussian calculation setup. Click on it. When you click on it, a new window will appear. Let me adjust it a bit. Okay, this is the window. This is the job title. You can calculate the energy, you can optimize, you can calculate the frequency, or you can optimize and frequency together, which gives you the OPT plus frequency, IRC. You can scan, you can test the stability, or you can perform NMR. For the first instance, I am going to choose the OPT plus frequency to see the optimization as well as the frequency option. When you choose it, the pop-up window will appear. How to optimize? We are going to minimum. You can also choose TS Barney, but minimum is the best. The force you want to use, the first point, the calculate all point, but we'll keep it on the default. Compute Raman spectra. Do you want the Raman spectra? So click on yes. And these are the other options. You can change according to your model, or you can, if you are following any research article, you can choose parameter according to it. The second thing is the method. In the method, this is the ground state. You can choose CSI, CS, TD, CSF, TDA form and so on. Here we are choosing the ground state and our target is DFT analysis. You can also use the mechanics. We will explain it later. Mechanics can be used for the larger molecules. So our main target is density function theory. So we are going to DFT analysis. This is the spin or default spin, and this is the model. There are multiple models, but by default model is B3LPY. They use the different algorithms. You can choose according to your research article you are going to follow, or if you have something special in it. Otherwise, click on the B3LYP. This is the default model. Now the next step is basic set. The basic set, normally we use the G-31 6-31G. This is basically the industry and educational standard normally used. The largest one is the LAN L2DZ. It is the largest library and cover whole the periodic table. If you are going to run the large simulation, then you can use it. Otherwise, the standard is G-31G, or you can also use SSD for the nanoparticles and so on. So in this tutorial, I am going to choose 6-31G, and here we are going to choose the D orbitals. D orbital means if you have any heavy atom, the heavy atom can be included in this D. If you don't have any heavy atom, you can simply choose none. So for this tutorial, I am going to choose the D. The next thing, the charge is neutral and the spin is singlet. Then give it a name. We are giving it the name such as demo, and link. This is basically the memory limit. You are using 100 MW 1000, and you can specify. If you are, this is basically the system settings. You are using the shared processor, you can use 1 2 3 and so on, checkpoints and read write. Otherwise these are not necessary. These are basically the general information. Use quadraticity, convergent CSF, ignore symmetry. If you need any special requirement, then use these functions. Otherwise keep them default. Then guess option, you can use the mix Homo and LUMO orbitals. If you don't check this, it will calculate Homo and LUMO orbital individually. These are basically the mixed orbital which are sharing the both Homo as well as LUMO orbital. If you are using CSF model, then you can use this one. You can save the orbital checkpoint during the simulation, generate the optimization or localize orbits. These are basically your MO theory parameters. Then these are the POP. These are by default setting. If you know you need a specific charges or the bioretro generalized orbitals or NTO orbitals, you can choose them. Solvation, if your model is in the water, you can choose any of them. Normally the water-based model or CSI PCM model is the best for the water-based model. Otherwise choose it as a none. And these are additional and preview, and that's it. When you have given the title and then submit the job. When you submit the job, it is asking you to save the file as input. Click on the save button. It will ask you the path. I am giving it the path on the desktop, and the desktop I have prepared a folder with the name DFT, and I am giving it to the name as demo 1 and save it. After saving the job is submitted, and check mark this one, notify when the job is finished, and click OK. When the job is gone, the previous window is closed. Now the new window is open. This new window is basically the Gaussian. At the start I told you that we don't need to open the Gaussian as separately, because when it is required, it simulate and connect to the Gaussian automatically. We are using the small molecule, so it will give the result into 3 to 5 minutes. But if you are using the very large molecule, you are using the protein molecule, it may take up to 2 or 3 days as well. Our job is completed and the option pop up that Gaussian has completed. Do you want to close the Gaussian window? Click on the yes. The Gaussian window is closed and this window will pop up. What this window tells us, these tell us the first window tell us that all the checkpoints and these are the time, and the second window is the log file. Basically this log file is important. You can see in the DFT folder, in our folder, these files are also present. This log file is also present. This is the check file and this is our running job simulation file. So check mark on it, uncheck on it and check mark on it and click on the open button. And when you open it, you will see the new window will be open. For clarity, I just closed the previous window and this is our result window. If this does not open, you can simply go to the file, go to the open, and here go to the DFT folder. In DFT folder you have the log file. Just click on it and open it, it will be open. Now we to analyze the result of this file. Just click on this window, right click on it and the result will appear. First go to the view and in the view click Cartesian axis. It will show you the axis. Now just let me adjust it. Here I am going to adjust it, and these are basically the axis molecule. Okay. Now the second step, right click on it and go to the result. In the result you will find the summary. This is the most important thing you can find. This is basically the job, file type, calculation type is frequency, calculation method is this one, basic set is this one, charge is 0. These are the information we provided. This is the important thing. This is the energy it is calculated, and this is RMS value, and this is the dipole moment, and this is the polarizability. Simply you can copy this information or you can simply save this information as well. You can go to the file and click on the save data. It will ask you where to save and in the text file. Simply demo1 text file, we will save it. The second column is the thermo. It is giving you the information like temperature, pressure, frequencies, electronic energy, 0 point energy, thermal enthalpy, correction, 0 point, and so on, and entropy, heat capacity, thermal energy, and the last one is the OPT, optimization. Optimization as maximum force, RMS force was optimized, and maximum displacement was optimized, and RMS displacement was optimized. So all this information is present. This is the basic information you will need from the DFT analysis, and it is also giving you the time it took about the 1 minute. If you have large molecule, it can take 2 to 3 days as well. Click on OK and this file is saved. Let me show you. Minimize this file, go to DFT folder. We have saved the file demo1.txt. It contains all the information we have just saved. Now come back to our this window. Go to the, again right click on this one, go to the result. You can also see the charge distribution. This is giving you the charge distribution, show by number, show by color atom. You can add the information as you like. You can show the vector. This is the vector one. This is the Mulliken charge. You can see the APT charge as well. Now again go to the result window. In the result window you can see the atom properties. These are the show by number, show by color, symmetric range, and fixed stage. These are by atomic number. Then again in the result we have bond properties. These are the bond length, order or length, show by the number. These are going to giving you the numbers. Then symmetric range, and so on. Then again to go to the results. In the result we have surface properties. You can add the surface over here. We are not going to discuss it here because it's not so much compulsory. Then again go to the results. This thing, the vibration, this is the important thing which I want to show you. Just let me adjust it. Here we have 1 2 3 4 5 6 atoms. So multiply by 3, 6 into 3 are 18. So total degree of freedom is 18. 3 goes to the rotation and 3 go to the, sorry, we will subtract 3 translations and 3 rotations. So total vibrations become 12, and here are the 12. So first click on this one and start the animation. You can see it is now rotating. If now click on this one, the angle of rotation is changed. You can click on this one, the angle is again changed. So you can see all the vibrational and rotation energy as well. If you want to show the displacement vector, this is the displacement vector, okay, how it is displaying. You can also see the manual displacement, or you can see different angle like this one. You can see these are the basically all rotational studies. If you want to save the movie, you can save the movie file and save the movie frame, or you can save the both. Simply save, click on it and save as a GIF file where you would like to show. This is the important thing. The next thing which we are going to explain is the spectra. If you click on the spectra, it is giving you the IR spectra and Raman spectra. If you click on this line, let's start animation. When you start animation, you click on any peak, it will show you the rotation. This is basically the predicted spectra. This is not the spectra. When you prepared a molecule, on the basis of calculation, it has predicted that this molecule has this kind of IR spectra, and this one is the Raman spectra. You can see this is the Raman spectra. You can save these plots, go to the plot and save as a picture, or you can save the data as well. Data can be saved as a text file. You can save the data as plots, and also you can save as a picture. It will ask you to where the save the picture and save it. So we have saved the both the data as well as the graph. You can see here is the Raman graph, and this is the text editor file saving all the coordinates. If you want to make graph from this coordinate, you can also prepare the graph. This is the Raman spectrum we have just saved. So this is, in this way you can calculate the values. Now I close this window and let me minimize it for the bit. This is this window. Now have a quick click on our file, go to DFT folder, and in which the initial log file, open this file, and from this file Control F and search for alpha. Here you can see there are alpha OCC equivalent. These are values for Homo, and DIRT, these are values for LUMO. These values were also present in the graphical interface in the GaussView. Also you can search for dipole, and these are basically the values of dipole moment which are present. Simply I need to close it, and here are some calculation. Homo is basically highest energy electron. You can search it alpha OCC eigenvalue. and LUMO is lowest empty surface. If you want to calculate the energy gap, subtract value of LUMO from the HOMO. If the gap is big, it says that these orbitals are stable. If the gap is small, it means they both HOMO and LUMO orbitals are reactive. These are some more information. If you want to calculate the ionization potential is IP is equal to minus HOMO, electron affinity is equal to EA is equal to minus LUMO, electronegativity is X is equal to IP plus EA. This one is IP and this one EA divided by 2, which calculate the Millikan electronegativity charge of IP and EA. And electrochemical potential mu can be calculated is equal to mu is equal to minus X, and then hardness can be calculated using this formula, and softness can be calculated using this formula, and electrophilicity index omega can be calculated using this formula. These formula can be valuable to calculate your in detail DFT analysis. So coming back to our original task, now I will explain if you have a bigger molecule like a peptide molecule or protein molecule, how you can calculate. Simply go to calculate, go to Gaussian calculation setup, and from this method you can choose OPT and frequency, and from method you can change DFT to mechanics or the semi-empirical. Mechanics is basically for the large molecules, and these are basically force field. You need to choose the force field. UFF is universal force field. Some people also use Dryden, and most commonly people use Amber-Freeze force, which is a very popular force field. So you need to just simply change the force field and the molecule. And the second thing, the next thing is, if you are working on the small molecule, you can choose only for the energy, and then the method you can choose the ground state. Here you can choose mechanics, semi-empirical or DFT analysis. Like in DFT analysis, some people choose, like if you are working on the nanoparticles, you choose the energy method, and then you choose from the method you choose DFT analysis, and after the DFT analysis you choose this one, SDD. SDD is method is best described for the quantification of the nanoparticles. Now I will explain that how you will draw or predict the UV spectra of a compound. Let's say this is our compound. For the same compound I want to predict the UV spectra. So I will go to calculation and go to Gaussian calculation setup. In the Gaussian calculated setup, first thing I will not choose OPT and frequency, like I will calculate the energy. In the method section, instead of the ground state, I will choose TD-SCF method, and from here I will choose the DFT analysis by default method, and from basic set I will choose G-31G without any orbital, and in the title I am going to give it to the new name as demo UV. Rest of the setting are kept as by default, and then submit the job. It will ask you to save the job. Yes, I'm going to save the job. I'm going to give it the name UV1 and save. It is asking me to notify the job. Yes, when the job will be complete, it will notify me. The job is completed. Click on the yes button. The window will pop up. Uncheck this one and open the log file and click on the open. Rest of the information is same, you can check. The thing I want to explain is right click on this window, this new window, go to result. In the result you can see here a new option is visible, which is UV visible spectra. If you click on it, you will see the UV visible spectra. This is the singlet. This shows that this is the maximum wavelength of this compound. Here you can save the plot, you can save the data, like I will save the data as UV visible, that I saved, and I will also save the picture and this is the picture will be saved, and data is saved and picture is saved. Go to my DFT folder, and here you can see this is demo UV visible graph which we have just saved. This is the graph, and this is our text file. In this text file all the information is present. The one more thing I want to explain over here, right click and create a new Excel sheet, then open this Excel sheet. I'm going to explain how you can export all the readings into the Excel. Go to the file and open, and from the file browse to your folder in which you have saved the data. This is DFT on my desktop, and click on the all files. From the all file I am going to search this one, demo UV1 visible data.txt. Select this file and open. When you open, an option will pop up. From this option select delimited, click on the next button, then select space, click on the next button and press finish. When you will be finished, it will be all data will be imported into your Excel in a correct format. Like if I want to make the graph from these values, select all these values. I have selected all these values. Now go to insert and go to the scatter chart and press this button. You can see the graph is shown. Now you can modify or change graph as per your need. One of the most important thing, don't forget to save this file, because this file is just important. It has not been yet saved. If you don't save it, when you close this file, everything will be vanished. So before closing it, save it. So this was the tutorial about the GaussView 6 and Gaussian for DFT analysis. If you have any query, please ask in the comment section. Please like and subscribe our channel for more upcoming interesting videos. Thank you so much for watching. Allah Hafiz.